Hello and welcome to my channel. Today we're going to test this servo motor. It costs around $70 and I already tested it in my previous video, so you can find it on my channel. And it's very powerful. It claims that it can handle 3 kg per meter and it has a quite huge backlash, but this is only $70. It has a magnetic encoder and does not have any bearing. It has only bushings. So let's see how it's performed. Over there you can see the magnet, and on other side on this PCB there is a magnetic encoder. This is a DC motor. It's a normal one with just 2 wires. Output shaft. This is a bushing and the second one is over there. And this is how it looks inside. So you see that all the gears except this one are metal, and there is 1, 2, 3, 4 gears, and this is the motor, the output shaft of the motor. The weight of this motor is 587 grams. This is an aluminum beam which I prepared to mount this motor, so I 3D printed these 2 brackets. So this is how it should be mounted. So the reducer is mounted, and now I can fix this on the side of the table. I also prepared this arm where I fixed with these 8M3 screws this wheel. This wheel comes originally with this servo and it can be fixed on the output shaft. So I fixed this arm on the output shaft. There is just enough space to move. So this is the backlash, and it also moves the sideways because these bushings are not perfect. To connect this servo, I'm gonna use this servo tester, and these 2 wires should be connected to the 24 volts. Now let's quickly see how it works. Okay, nothing is broken. Good. It has a nice amplitude. So to see the amplitude I will dismount this. So this is one limit position. And this is another limit position. So it's like more than 270 degrees. And this is the maximum speed. So from one position to another, from one position to another. Nice. This is 1 kilo. This is 1 kilo, so this is what I'm going to use for the first test. 2 kg load. So I have 2 kilo in this bag, and this bag is attached with this rope to the output arm. Oh, it does not hold without power, so let's switch it on. Yes. Okay, it holds. This is 2 kg of load. It handles 2 kg quite easily. This is a view from other angle. So 2 kg of load is not a problem for this servo motor, at least with this length of the arm. I should say that this servo motor is kind of not backdrivable, because there is a lot of gear ratio, and so it's quite difficult to move it to backdrive the motor, and I'm gonna do this really slowly in order not to break the gears. It's backdrivable but not really backdrivable. I think if I'll hit it like this, I'm gonna break the gears. Let's continue our test with a longer arm. I have this another aluminum beam which I can fix over here. So this longer arm is fixed. So 2 kg load on 86 cm 1 mm long arm. Let's do this. Okay, let's see how it's gonna handle it. First of all, I'm gonna switch off the power. So it's on. So it does work. And now let's put a 2 kg load. I hope it's not gonna break. It holds just barely. Okay, it does work. I don't wanna move it very quickly. The motor is cold, the electronics a little bit hot. Let's increase the payload. So we're gonna add this to the payload. This is 500 gram. And this is also 500 gram. So now the next payload is gonna be 3 kg. Let's see if it can handle it. The power is on. Okay. Now let's put the load. Okay, now the load is on the floor. Let's see if it can lift it up from the floor. Yes, it can. 3 kg. Oof, it sounds bad. Yeah, I think it's broken. Let's switch it off. This was scary. You can see that payload was really 3 kg. It's 3.043 kg. Quite close to the 3 kg. And this arm is less than 1 meter. So the torque which we applied was less than 3 kg per meter. I dismounted the motor and I saw that there is damage on the shaft, and this damage comes from this wheel on which the arm was fixed, and this wheel has this screw which hold this wheel on the shaft, and this screw went inside the shaft, you see. It makes this hole. And so that's why from this side the shaft becomes a little bit larger, and it was difficult to take off this wheel. So let's see what is inside. So I unscrewed all the bolts, and let's see what is inside. Now I cannot take it off because of this shaft damaged. Oh, I see where is the problem. You see this broken gear. Let me try to unmount it. Yes. You see this gear completely broken. So I think we can conclude that it cannot really hold the 3 kg per meter. This is bad. I cannot repair this. Okay, but at least we learned something. So today we tested this servo motor. The name of this servo motor is Super300. Why 300? Because they claim that this servo motor can handle 300 kilograms per centimeter or 3 kg per meter torque. So today we tested this. First of all, we tested the backlash, and we saw that backlash is quite high. It's around 0.77 degrees. But afterwards we tested the torque. We tested the torque with the 2 kg payload and this arm. This arm has a weight, and that's why we need to correct for this weight here. And the total torque which we used was 2 kg per meter, and this servo handled it quite well. Afterwards we increased the payload, so we put a 3 kg on the same arm, and we had a maximum torque of 2.87 kg per meter, and this time we broke the gear. This means that in practical situation this servo motor cannot handle 3 kg per meter. Maybe it can handle in some like really theoretical cases when the arm moves like super slowly, but not in the real case. Even in my video I tried to move this arm very slowly and to be gentle with it. But it's actually quite nice how it's broke the gears. This means that we will continue building a 3 kg per meter actuator for our future robotic arm. And in order not to miss this video, don't forget to subscribe to this channel. Also, I would like to say a huge thank you to my patrons. Here are their names, and thanks to them I will continue building human-like robotic arm. If you would like to support my channel, please like it, share it in your social media. Don't forget to put a comment, and also you can support my channel via PayPal or Patreon. All the links down below in the description. See you next time.